Several couples arrive at a dinner party. Each person at the party shakes hand of every other person, not including his or her spouse. If there were a total of 112 handshakes, how many couples attended the party? So we start counting, and the number of couples and the number of handshakes, and we form a sequence, and then we find the nth term of the sequence, and then we can find if the if there were 112 handshakes, so how many couples attended the party. So we start with, so suppose AB was a couple, and so the number of couples is 1, and there would be 0 handshakes because between them the couples handshakes don't count. So then say C and D join them. So when C and D join them, you would have 2 couples, and the number of handshakes then would be, you see, A would shake hands with C and D, and B would also shake hands with C and D. So there would be 4 handshakes. Now suppose we have 2 other couples joining them. So E and F have also come. So there would be 3 couples, and the number of handshakes. So A would now shake hands with E and F. So A has shaken hands with C, D, E, and F, and similar to B. B would also shake hands with E, F, C, D. Now, between them, C, D, E, F also have to shake hands. C cannot shake D's hand. C and D are a couple. But C shakes E and F's hand. So there would be 2 more handshakes with C and 2 more handshakes with D. So the total number of handshakes in this case would be 12. So now we add 2 more people to it. So add another couple, GH, and see what happens to this sequence of numbers in the handshake. So we have 4 couples, and you see what happens now is individually A would shake hands with G and H. So the B would shake hands with G and H, and C and D would both shake hands with G and H, and then E and F would also shake hands with G and H. So it would go like this, and then 24, yes. So E and would also shake hands with G and H, and F would shake hands with G and H. So you would have a total of plus 12. So here you see in this case there were 4 handshakes, you add 2 to it. There were 4 handshakes, you add 2, and here there were 2 handshakes, so 2 more added, 2 handshakes, 2 more added, and here 1, 2, 3, 4 more handshakes have been added. So we've added 12 more to the existing 12, so the total would be 24. So the sequence of numbers then is 0, 4, 12, 24, and we need to find the nth term of this sequence because more couples are added, and ultimately this number becomes 112. So if we do the maths now here with the sequence, so 0, 4, 12, 24, and we find the common difference, that would be 112 in the end, right? So the common difference, we get 4, 0 plus 4 is 4, 4 plus 8 is 12, 12 plus 12 is 24. Then we go down to the second level of common difference, and we see it is 4. Now there are several ways to work out the nth term, so I have used one way. You don't have to follow my method. But anyway, what I did is, so if you have 4, this is probably what everybody would do. If you have 4 as the second level of difference, you half it, and then, so the quadratic sequence, an square plus bn plus c, and a would be 2. So the coefficient of n square would be 2. N is the number of terms here. So then we write it as 2n square plus bn plus c. Now to find b and c, we see the first term is 0, the second term is 4, the third term is 12, the fourth term is 24. So I can say the first term is 0, so I can write 2 times 1 plus b times 1 plus c is 0. it should be 1 square, but 1 square is 1. So I get the equation b plus c is 2. So the second term now is 4. So I can now similarly write 2 times 2 square plus b times 2 plus c is 4. So I would get 2b plus c is 4 minus 8. So this is 8. It goes to the right hand side. So 4 minus 8, I get minus 4. So now I solve these two equations simultaneously, and I would get c is 0 and I would get b is minus 2. So I would, get the sequence, put this value of b and c here. So the sequence would be 2n squared minus 2n, and hence this to find, the number of the value of n, this would total 112. This is what we need. So I wrote down 2n squared minus 2n is 112, n squared minus n minus 56 is 0, and if you factorize it, you get n is 8. N cannot be negative, so we don't have n is minus 7, so n is 8. So hence there were 8 couples that attended the party, and that is the answer.